Right now, you are touching something: a chair, a floor, this screen. It feels solid and certain. But that feeling is one of the strangest illusions in all of physics, because almost nothing you have ever touched was truly solid. And in a strict physical sense, you have never actually touched anything at all. To understand why, we have to shrink down past skin, past cells, past molecules, into the hidden architecture that everything, including you, is built from. What we find there is mostly emptiness, a vast, silent space, holding a few tiny specks that somehow build tables, planets, and people. Start with your hand. It looks continuous and full, but zoom in, and that smooth surface breaks apart into a landscape of individual cells. Zoom into one cell, and it too is mostly bustling machinery and water, built from smaller pieces still. Molecules, linking together like tiny tinker toys. Zoom into a molecule, and it splits into atoms. The small, stubborn building blocks that the ancient Greeks imagined could never be cut in two. For 2,000 years, we pictured atoms as tiny, solid marbles, hard little balls packed together to make solid stuff. That picture is beautifully, completely wrong, because an atom is almost entirely empty space. At its center sits a dense core, the nucleus, holding nearly all of the atom's mass in a vanishingly small dot. Around that core, the electrons, not neat little orbits like planets, but a faint, blurry haze of possibility, smeared across a huge empty volume. How empty is it really? Imagine blowing one atom up to the size of a grand cathedral. The dense nucleus would be a single grain of salt, hovering in the middle. Everything else, the entire cathedral, is empty. The electrons flicker somewhere near the distant walls. Between them and the core lies nothing at all. If you removed all the empty space from every atom in every human on Earth, the entire species would compress down to the size of a single sugar cube. That is the truth hiding inside solid matter. You are not a solid object. You are a shimmering, mostly empty cloud of tiny charges, holding a roughly human shape. Which brings us to the mystery. If you are mostly empty space, and the floor is mostly empty space, why don't you simply sink straight through it? Two clouds of almost nothing meet, and instead of slipping past each other, they lock into place as if they were utterly, impossibly solid. The answer is not in the specks themselves. It is in the invisible forces that surround them, fields that reach out across the emptiness and push back hard. To really feel why you can't fall through your chair, we need to meet the forces that rule this tiny world. There are four of them. Two of them, the strong and the weak nuclear forces, work only deep inside the nucleus, far too short range to matter for the surface of your skin. A third, gravity, is by far the weakest. It shapes galaxies, yet a single fridge magnet can lift a paperclip against the entire pull of the planet. That leaves the force that actually runs your daily life: electromagnetism, the force between charges, the reason light exists, and the reason solid things feel solid. Every electron carries a negative charge, and one of the first rules we learn about charges is simple. Like charges repel, push two of the same together, and they resist. Now remember where the electrons live, on the outside of every atom, forming its entire outer surface. The skin of all matter is made of electrons. So when your hand approaches the table, what actually meets is not matter and matter. It is electrons meeting electrons. negative meeting negative. Repulsion. As the two surfaces get closer, the repulsion grows astonishingly fast. A tiny step nearer, and the pushback multiplies, climbing steeply, like a wall rising out of the ground. Long before any particles could ever collide, this force has already won. The surfaces are held apart by a cushion of pure electromagnetic resistance. This is what touch really is. Not contact, a conversation between fields, where your electrons and the world's electrons negotiate a tiny, permanent distance. The hardest granite, the coldest steel, the gentlest handshake. All of it is the same trembling electromagnetic standoff, scaled up to a size you can feel. But electromagnetism alone is not the whole story. There is a second, stranger rule keeping you from collapsing. One that has nothing to do with charge at all. Meet one of the deepest laws in nature, the Pauli exclusion principle. It says that no two electrons can ever occupy the exact same quantum state at the same time. Think of electrons as impossibly antisocial. Each one demands its own private address. Try to force two into the same place and the same state, and nature simply forbids it. This isn't a force pushing them apart in the usual sense. It is a rule woven into the fabric of reality, deeper than any push or pull. When you press two objects together, you try to squeeze their electrons into a smaller space, crowding their states. The exclusion principle shoves back with ferocious strength. This resistance has a name: degeneracy pressure. It is not heat, not charge, not motion. It is the universe refusing to let identical things share the same room. Most of the firmness you feel, the resistance of a desk, a wall, your own bones, is really this quiet refusal, happening trillions of times beneath your fingertips. And this same rule scales to the most extreme objects in the cosmos. When a star like our sun dies, gravity crushes its core inward with unimaginable force. Nothing ordinary could survive that crush. But the electrons inside, forbidden from sharing states, push back and hold up an entire dead star against its own gravity. We call that surviving ember, a white dwarf, a sun-sized mass squeezed into the size of the Earth, kept from collapse by the very same principle in your hand. Push even harder with a heavier star, and even the electrons give way. They merge with protons, and matter falls to a new, denser refuge. Neutrons. A neutron star packs more than a sun into a city-sized sphere. A single teaspoon of it would weigh as much as a mountain, still held up by the exclusion principle. To go deeper, we have to give up the idea of particles as tiny balls entirely. In our best physics, there are no little marbles. There are only fields. Reality is layered with invisible fields, filling all of space. And what we call a particle is just a tight little ripple, a vibration humming in one of those fields. An electron is a ripple in the electron field. Light is a ripple in the electromagnetic field. You are an unimaginably complex chord, played across many fields at once. So when your hand meets the table, two enormous patterns of vibration push against each other, and the fields between them stiffen into what you feel as solidity. There is no final, tiny, solid thing at the bottom. Solidity is not made of stuff. It is made of rules, fields, and resistance, all the way down. Let's return to your own body and ask what feeling really means. When you press your finger to a surface, no surface ever enters you. Instead, the electrons in your skin are pushed just slightly. That push bends molecules, which open tiny gates in your nerve cells, releasing a pulse of electricity. That electrical pulse races up your arm to your brain, and only there, in the dark, does the sensation of touch get built. A story your mind tells about a force. You have never felt an object. You have only ever felt the electromagnetic push of its surface, translated into a signal, interpreted by a mind in total darkness. Warmth, texture, pressure, the weight of a hand in yours. Every one of them is electromagnetism, retold as feeling. Touch is the brain's beautiful translation of a force. Step back, and the ordinary world transforms. The chair beneath you is not holding you. Its electrons are refusing to share space with yours. Trillions of times per second, you float, ever so slightly, above everything you ever sat on, leaned against, or held. A permanent, invisible cushion separates you from the entire physical world. When two people hold hands, their atoms never meet. Their electrons hover a whisper apart, trading forces across a gap that can never fully close. And yet, nothing about that connection is less real. The force is real. The signal is real. The warmth your mind builds from it is as real as anything can be. We spend our lives certain that the world is solid, certain that we touch it. Both feelings are stories, useful, vivid stories, told by a brain doing its best. Underneath the story is something stranger and grander, a universe of empty space, threaded with invisible fields, holding itself apart through rules we are only beginning to grasp. You are part of that universe, a pattern of vibration, a cloud of charge, a self-aware ripple that learned to wonder why it cannot fall through the floor. So the next time you touch something, pause, feel the faint electric standoff of it, and remember, you have never touched anything, and you never will. Isn't that beautiful?